In this last section, we're going to look at how calculators can help us solve systems of equations. And they can do this by using what is called a matrix. And that's this first blank. A matrix is used to display information to solve a system of linear equations. This title of the section, Matrices, is the plural. So the first thing, we're going to look at two different ways to use matrices to solve systems of equations. And the first one is using what's called an augmented matrix. So these three equations we're going to solve all together. And, well, we're not going to solve this one, but we will in a minute. But we're going to use this to write an augmented matrix. So a matrix has a big bracket like this. And then it puts all the numbers that go in front of x in the first column, all the numbers in front of y in the second column, all the numbers in front of z in the third column. And then there's a vertical line where the equal sign goes, and then there's the number at the end over here. And then there's another bracket. So this first equation would have a 1 in front of the y, so it would be a 3 in front of the x, a 1 in front of the y, a 2 in front of the z. We don't write the equal sign because of that vertical line, but then that 31 goes over here. And the next equation, we'd have a 1 in front of the x and a 1 in front of the y. So we'd have 1, 1, and then a 2 in front of the z, and then the number 19 over here by itself. In the third equation, there'd be 1 in front of the x, a 3 in front of the y, a 2 in front of the z, and then a 25 over here on its own. And that is the augmented matrix. Augmented means to make bigger, and that's, they mean it's made bigger by this last row of numbers over here on the other side of that vertical line. Okay, so this is another chance to do the same thing. We have these equations that we're solving together. And so we're going to write our augmented matrix. Remember that we have x's and then y's and then z's, a vertical line, and then our number, and then another bracket. So there's a 1 in front of the x in the first line, a 2, and then a negative 5, and then negative 19 over here by itself. Now in the next equation, you notice that there's no x. That means it's really 0x plus 1y. So we'd write 0, 1, 3, and then 9. And in the last equation, there's no x, so that'd be a 0. There's no y, so that would be a 0. There's a 1 in front of the z, and then the 4 by itself. And then this is our augmented matrix. So this matrix, I couldn't get it to type up nicely, but this has got the brackets on the end and the line right here. And we want to write the equations that are represented by this. So remember, the first column is x's and then y's and then z's, and then this vertical lines are equal sign. So the first line would be 2x. There'd be, you can write plus 0y, but the 0 means there isn't a y, so usually we would just write plus 7z equals negative 13. The next equation tells us there's no x, so we usually would just not write the x. And then so we'd have 1y, or just y, minus 6z equals 15. And in the last equation, the 0 in the z column tells us that there's no z, so we would just write 7x plus 3y equals 5. And usually when we write our equations, we want the x's lined up, the y's lined up, the z's lined up, the equal signs lined up, and then the numbers lined up. So that's why I tried to kind of leave an empty spot right here and an empty spot right here. And really this would be better on the top equation if I'd left an empty spot right here and kind of put plus 7z more over a little bit. And then these are hooked together because all three equations go together. Now if they're not all lined up neatly like that with the equal sign, the x's and the y's and z's, that's okay. You just have to have the right number in front of the right letter. Okay, so now we're going to talk about how we use our calculators to solve these. So the first step in using our calculators is that we have to write our augmented matrix. So we'd have 2, 1, 2, 18. Here's our line. And then 1, -1, 2, 9. 1, 2, -1, and 6. Okay, so now let's talk about how we put that into our calculator. In your graphing calculator, there is a matrix button, and you type that first, or hit that button first. When you hit matrix, it might be a second button and then matrix. You have to arrow over to edit. Edit is the category that lets us enter a matrix into our calculator. So if you go over to edit and then hit enter, then you'll see a spot where it's blinking kind of at the top, and it's waiting for you, and it'll say something like that. It's waiting for you to tell it how many rows you want. Rows is the first blank, and that's how many lines across. And then columns is the second blank, and that's how many up and down there are. So in this equation, in this system, we have 3 rows. So we put 3 in this first spot and then hit enter. And then there's 4 columns. So we put 4 columns. So we put 4 in the second blank and then hit enter. If you hit enter after each number, it'll move you straight across. And then to enter the numbers, you just type in the numbers you see. You'll type 2 and then enter, and then 1 and then enter, then 2, then enter, then 18, then enter. And then it'll come back for the next row. 1 and then enter, -1, enter, 2, enter, 9, enter. If you just keep hitting enter after each number, it will move you to the next spot automatically. So you're going to do that till you have entered all 3 rows. And then when you've entered all 3 rows, you're going to hit second, quit. And that saves that matrix in your calculator. We put it in the A spot, so it's matrix A. So do that, pause the video, do that, and then restart the video. Now to do something with that matrix, we have to tell the calculator what to do. So after we've got that matrix entered, we're going to go back to matrix, and then arrow over to math, and then hit enter. When we do that, then we have to choose what math we want the calculator to do. And this right here tells us what we're going to use. It's called reduced row echelon form. And so what we're looking for is RREF. You don't have to know what that stands for, you just need to remember that that's what you're looking for. So if you arrow down, you have to arrow down quite a long ways to get there. But you'll see it, and then you hit enter. And then we have to tell it what matrix to use. So you go back into matrix, and it's already where it needs to be, so you just hit enter. And so what you should see on your screen is RREF parenthesis matrix A. That's where we typed in our matrix. And then you can just close it with a parenthesis and hit enter. And what you'll see now on your screen is this matrix. Let me create a spot for it. So what you should see is 1 0 0 5 0 1 0 2 0 0 1 3. This is a new augmented matrix, so go ahead and put your line in that spot where it goes. And remember that just like before, this first column is our x's, the second column is our y's, the third column is z's, and then we have equals our number. So if we read this first equation, that's telling us that x, because 1 is in the x column, is equal to 5. This middle row is telling us 1 is in the y column, so y is equal to 2. And then this last row is telling us 1 is in the z column, so z is equal to 3. So it's telling us our answer there. We're going to write that as a pair, as a point. So it would be 5, 2, 3. And this is our answer. That's the x, the y, and the z that work in all 3 of those equations at the same time. We'll do another one, but we'll notice that these first 2 equations aren't in the right format. We need to move the z to the other side first. So we'll subtract z. So we get x minus 7y minus z equals negative 16. Here we need to move the y and the z. So we have x, we subtract y, and then we add z equals 2. And the last equation is in the right format. So we'll just copy it. So this is our system of equations. So the first thing that we'd write down is our augmented matrix. We'd have 1, negative 7, negative 1, negative 16. There's our line. 1, negative 1, 1, 2, 1, 1, 7, 24. So then we're going to go to our matrix button. We'll hit second matrix. And we have to type in that equation, that matrix. And we're going to type it just over top of the other one. It already tells us, we already know it's a 3 by 4, and it already has that. So you can just hit enter, enter. And then you can type in your numbers. Just remember, just hit enter after each number. And I'll pause it and get it typed in, and then we can restart it. Remember to hit second, quit, that's at the very top, to save it. And then we're going to do the math with it. So we'll go back to matrix math and find RREF. Hit enter. And then we want to tell it that we want to use matrix A. So we go back to second matrix or matrix and then just hit enter. And close the parentheses and then hit enter. And you should get this matrix. 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 3. This is where our line would go right before that last column of numbers. This is x, this is y, this is z. This is our number. So this first row tells us that x is equal to 1. Second row tells us that y is equal to 2. And the third row tells us that z is equal to 3. So we'd write that as a point. 1, 2, 3. Doing this by hand without your calculator takes a really long time. So the calculator does all the hard work for us. We just have to learn how to get it into our calculator correctly. Okay, so we're going to switch gears a little bit. We're going to talk about a whole different way of doing matrices with our calculator, or solving problems with matrices. And the first thing we need to know about is how to find a determinant of a 2 by 2. So let's say that we have a 2 by 2 matrix, A, B, C, D. And we want to find the determinant. The determinant is just a single number that represents that matrix. And when we're finding determinants, we use straight lines on either side of the matrix. It's a little bit like having an absolute value for that. And the way we find the determinant is we take these two and multiply them together, AD, and then we subtract these two multiplied together, BC. Okay, so it's always this diagonal minus this diagonal. So let's try that. So here's a determinant. We're going to put straight lines on either side. So we're going to start off by doing 10 times 5, and then we'll subtract 6 times 9. So we get 50 minus 54, and we have -4 as our answer. We'll do the same thing with this one. So we have 2 times -5, and then we subtract, and then 4 times -3. So it's this diagonal minus this diagonal. So we get -10 minus a -12, or that would be -10 plus 12, and that gives us 2 as our answer. So here's how we use this if we have a system of equations. To find x, we find x and y separately, and we do it as sort of a fraction for each of them. In the bottom of the fraction, we write a matrix that uses just the numbers that are in front of x and y. So we'd have, in this case, we'd have A1, B1, A2, B2. It's just the x column and the y column. And it's the same on both. To find both x and y, we use the same denominator for those two fractions. Now to do the determinant on the top, if we're finding x, we replace the numbers that are in the x column with those numbers that are by themselves. So the x column becomes C1 and C2. The y column stays the same as whatever numbers were in front of y. To find y, the x column stays the same. We don't change x because we're not finding x. But we take the number column and we put it in place of y. Okay, so the number, whatever we're finding are the numbers that get replaced. The other letter stays the same. You can see that here, this column, the y column stays the same on the top and the bottom because we're finding x. And here the x column stays the same on the top and the bottom because we're finding y. So let's try a couple problems. So we'll find the x first. So our denominator, we'll use just the numbers that are in front of the x's and the number that are in front of the y's. So we'll have 5, 3, and 4, -6. Okay, and we'll come back and we'll solve that in just a second. On the top, because we're finding x, we put the numbers in the x column, 12, 24. And then the y column stays the same. Let's go ahead and set up our y at the same time. The denominator is the same. We just use the x's and the y's as they are in the problem. But in the numerator, because we're finding y, we put the 12 and 24 in the y column, and we keep the x column the same. Okay? So if we finish the x's, we would take 12 times -6, which is -72, minus 4 times 24, which is 96, and -72 minus 96 is -168. In the denominator, we'd have 5 times -6, which is -30, minus 4 times 3 is 12. So -30 minus 12 is -42. And then we divide negative 168 divided by negative 42. And that tells us that x is equal to 4. So we'll do the same thing with the y's. Here we'd have 5 times 24 would equal 120 minus 3 times 12 is 36 over. Here we have 5 times negative 6 is negative 30 minus 4 times 3, which is 12. So 120 minus 36 on the top gives us 84. On the bottom we get negative 42. And 84 divided by negative 42 is negative 2. So we know y is negative 2. And then we just write our answer as a point. 4, negative 2. Let's do one more. So we're going to start by finding our x. So we're going to have our bottom. We just use the numbers that are in the normal x and y spots. On the top, because we're finding x, we put the last column in the x spot. So here we'd have 14 times negative 4, which is negative 56, minus 1 times 7 is 7. On the bottom we'd have 4 times negative 4, which is negative 16, minus 5 times 1, which is 5. Negative 56 minus 7 is negative 63. Negative 16 minus 5 is negative 21. And negative 63 divided by negative 21 is 3. So now we'll do our y's. On the bottom we just use the same matrix, the x's and the y's as normal. But on the top, because we're finding y, we put that 14 and the 7 in the y column and we keep the x's. So we'd have 4 times 7 is 28 minus 5 times 14 is 70. On the bottom we'd have 4 times negative 4 is negative 16 minus 5 times 1 is 5. 28 minus 70 on the top gives us negative 42. Negative 16 minus 5 is negative 21. If you take negative 42 divided by negative 21, you get 2. So our answer is 3, 2.